Okay, well, that's enough minutes for the late people to show up, so let's get started. So I'm Mark Stem with Sysdig, and today we're going to talk about Sysdig Falco, the behavioral activity monitor with container support. The plan is we'll kind of talk for about 20 minutes, do about 20 minutes of demos, and so that should leave plenty of time for questions. So if you have questions, kind of wait for the end, but if anything's unclear, definitely pipe up and we'll get everything figured out. Okay? So let's start with kind of an analogy based on home security. So if you think about the components of a home security system, there's a lot of pieces that are designed to prevent somebody from getting into your house. So there's things like door locks, sensors on the windows, bars on the ground floor windows, cameras, and so forth. And so the goal of all those things is to prevent somebody from getting in. But there are also other pieces of home security that are designed to detect that an intrusion has occurred. So there's motion sensors inside the house, I guess if you're a bank, there's lasers and stuff. But the idea is that they have two separate goals, but they're both really important for home security. So preventing intrusion and detecting intrusion. So if we take that analogy and move it over to computer security, you can see the same kind of breakdown. So there's a lot of techniques that are designed to prevent intrusion, passwords, two-factor authentication, fixing software vulnerabilities so nobody can get in, firewalls to limit network access. But there's also a need for security components that detect that an intrusion has occurred. And that's where Sysdig Falco comes in. The idea is that it detects suspicious behavior that is indicative of an ongoing intrusion. And just like in home security, both of these methods are really essential to have full levels of protection. So that's where we think Sysdig Falco comes in. So just to give a quick overview of what Sysdig Falco is, it's a behavioral activity monitor. So the idea is that it detects suspicious activity as defined by a set of rules that are associated with the product. The nice thing about it is that it uses Sysdig's capabilities for starting with system calls and building that up into a rich set of information, and also giving you a great way to filter that set of information using filtering expressions. So we kind of start with all the great things that Sysdig has and build up a rule system on top of that. And because it uses Sysdig's capabilities for system call analysis, you get all of the great things that Sysdig gives you right off the bat. So it has full support for containers, Kubernetes, Mesos, and everything. So it gets you a great way to power the set of rules that Falco provides. Falco has a bunch of flexible notification methods. So when you detect this suspicious activity, you can send alerts to files, you can send to standard output, you can write to syslog. So gives you a lot of channels that you can pass these alerts on to. And it's open source, so anybody can contribute new rules, you can make improvements to the software, you can see how everything works, so all the great things that open source provides, just like Sysdig. So let's give you a little bit of a teaser and kind of talk about some of the things that Falco can do and detect. And we'll just kind of give you like the kind of the snippets of how you would actually detect that in Falco. So let's say if you wanted to see that somebody's running a shell inside a container. On a general Linux system, you would definitely expect shells to be running, but within containers, they're usually used for kind of discrete programs like database servers and web servers, and you don't expect general purpose shells to normally be running. So if you want to detect that, here's the filtering expression that you could use. It's just as simple as saying the container.id is not the host, and the process name being run is bash. So pretty simple, but it gives you a great way to detect bad behavior. If you wanted to say, okay, so some like rootkit software, they try to install things in bin that they might like overwrite bin ls to be, it's not ls anymore, it's some malware software or rootkit software. So the way to detect that is really simple. You just say, is the directory of the file being written to one of these known binary directories? And is it a write? That's actually, that word write is actually a macro reference. We'll talk about that in a couple of slides, but it is a concise way to say somebody's trying to write a file. Another thing to look for is somebody trying to change their namespace. So are they trying to break out of the container they're in to get visibility into the host system? Are they trying to masquerade as one container or another? That's not something you would normally expect to see. And if you want to detect that, here's how you would do it. You would just look for the event type being the system call setNS. And there are certain programs that you would expect to do that, like Docker and Sysdig. And so if it's not one of those, then it's some suspicious activity. Kind of like the overwrite system binaries, some rootkits, they actually install software in dev because it's a widely accessible directory and has a bunch of stuff in it, and people don't normally think to look there. So here's the filtering expression that you could use to detect that. So you're looking for a create. Is it not a process that you would expect to be doing that? Is the directory dev, and is not dev null? So here's a fun one. You may, in the last couple of weeks, there's this story about how Mark Zuckerberg puts a piece of tape over his laptop camera to make sure nobody can spy on him. So that's a great way to do it. But if you also wanted to do that using Sysdig Falco, here's how you would do it. You would just say, okay, is somebody trying to open? Are they trying to open the video device? And is it not one of the programs that I would reasonably expect to be opening the video device? So sure, tape's good, but Sysdig Falco can do that and much, much more. Okay, so now we got a teaser. So let's kind of dive into Falco a little bit more and kind of show you how it processes everything from the lowest level system calls out to the alerts that go out. So this leftmost column, most of these capabilities are actually coming from Sysdig. So it starts with the same Sysdig probe kernel module that exists for Sysdig. Falco uses the same kernel module. So from that, it taps into the stream of system calls across the entire system. That goes up, that gets passed up to user space. And then there's libraries that basically take these system calls and transform them into events. So it basically does aggregation, deeper analysis to associate system calls with the process that's running it, kind of fully resolves file descriptors and network connections, and gives you a richer view into those set of system calls. Once you have the events, it goes through a filtering expression. So Sysdig already has filtering capabilities. It's just the thing you type on the command line to basically filter out the events you want. Falco uses that same capability, but in this case, it's being powered by a set of rules that come with Falco. So you take the rules that are in Falco, turn them into a filtering expression, and basically filter the set of events into a set of suspicious events. And the idea is that the events that come through the filtering expression are basically things that merit attention. Once you come through the filtering expression, now you have the suspicious events, you go through the alerting module. This is also controlled by the set of Falco rules. We'll see in a couple of slides, but each of these rules has basically, when an event happens, what message should you send and and what severity should you attach to the message. So that's handled by the alerting module. Once the alert gets created, it gets piped to a variety of different channels. So like we said, it can go to a syslog, you can write it to a file, you can write it to standard output. And from then, it's kind of, the administrator takes a look at these alerts and tries to figure out what's going on. Okay, so we talked about the rules a little bit on the last slide. Let's kind of show an example of what these rules actually look like. So with Falco, there's a file, falcorules.yaml, and it has the entire rule set. Within that file, there are two types of items. There are rules and macros. So here's an example. We'll just go through it really quick. A macro is kind of a way to avoid repeating commonly used filter expression snippets through the file. So you just, if you have something common like, okay, this is something related to a binary directory, you define that in a macro, and then you can use it in multiple rules without having to copy it over and over. Here's an example rule. So it has a bunch of components. We'll kind of go through each of these in a second. But the general idea is that a rule has a name, a description that says kind of describes what the rule is, kind of like what you can do with Sysdig. There are command line options to basically say, hey, tell me what all the rules are, or describe what this rule is. And so that's how that description plays in. The condition is basically the Sysdig filtering expression that gets applied to the events. The output is the message that you send, and it's got a priority. So within the file, we got a bunch of macros and a bunch of rules, and the rules kind of define the suspicious behavior that is the stuff that you want to take a look at. Okay, so let's just define what's in macros and rules and go through each of these fields. I kind of talked about it briefly on the last slide, but we'll go through each one. So every macro has a name. That name is basically the text that you use in later rules. So just going back one slide. So macro is bindir, so that's the name. And if you want to use that macro, you just put bindir in your later rules. And every macro has a condition. This is a filtering expression snippet. It's usually a piece of a filtering expression that you can plug into other conditions and get a full filtering expression. So here's the component of rules. Every rule has a name. That's just a way to identify it. Every rule has a description. Every rule has a condition. So this, again, is a filtering expression, just like you would see in Sysdig. One difference is that it can contain these macro references to avoid super long filtering expressions. Every rule has an output. So when one of these rules occurs, you take the output field and kind of construct a message based on that output field. It has, just like with Sysdig, it has the ability to kind of insert information from the event being processed, kind of like printf or sprintf. And every rule has a priority, so you can categorize based on really important stuff, not so important stuff, that kind of thing. So, okay, just looking a little bit more at what the filtering expressions are. Like we said, it's the same format as Sysdig, so you can do all the great things that you can do with Sysdig in Falco. So you can refer to container names, Kubernetes, Mesos, and there's full support for all of that. All of the Falco rules are basically combined into one gigantic filtering expression joined by ORs. So if you have 20 rules in your file, what gets passed to the filtering expression is a 20-step giant filtering expression with ORs. So that can get actually pretty long. So to make sure that that's still efficient, we have I guess a rule about rules. Every rule has to contain exactly one, or at least one, event type expression. So every rule has to limit the events for which the rule should be applied. We do that to basically allow for really fast initial categorization of events. So you can kind of only run the rule snippets related to a given event and not have to go through, each branch of that gigantic OR statement. So. Okay, so once something passes through the filtering expression, now we have some suspicious activity. And so each of these events now becomes an alert. The rule's output field is used to format that event into an alert message. It contains a mix of text and fields that you might find from the event. Once the event message has been formatted, we have to decide where it goes. And so that's controlled by the Falco main configuration file. This is separate from the rules file, but it's fairly simple. I don't even need to include it, but it's just very basically saying, okay, do alerts go to syslog or files or standard output or all three or some subset? And you have control over where they go. You can specify that in the config file or on the command line. It's pretty flexible. Okay, so at this point, I'm sure you're really excited to go install it. So here's all the ways you can install it. Maybe don't do it right now because I have great demos to show you too. So you're going to want to wait for that. But you can install it via all the normal methods. It's packaged as a Debian package, a Red Hat package. We've got an all-in-one installer script that you can download and run as root. It's kind of funny. We'll actually talk about why that may not be such a great idea later in the demo. We had a little blog post about it. But we also talk about how Falco makes it a lot safer. And of course, you can download a container that has Falco built in and allows you to run it without doing a bunch of initial steps. And then on our wiki page on GitHub, we've got the full instructions, so you can take a look there if you want to install everything yourselves. You don't have to cut and paste this stuff right now, I promise. Okay, so once you've got it installed, so running it is really simple. By default, if you install it via Debian or Red Hat, it is a systemd service. You can just say service Falco start, and it runs it as a background daemon, and it alerts to syslog. So that's one way to kind of monitor your host system. If you want to run it by hand, you can certainly do that as well. There's command line options to specify what the rules are, the config file, the options, and so forth. Pretty straightforward. In that case, it alerts to syslog and standard out. If you want to run it via Docker, well, there's the big old Docker run command. Don't worry, it's also on the wiki page, so you don't have to type it in madly. But the idea is that it's a fairly long command because it has to just like Sysdig does, it has to do a lot of things to bring in pieces of the host system into the container so it can monitor all those aspects of the host system. Okay, so any questions so far, or should we jump into the demo? All right, let's jump into the demo. Okay, so what we're going to do is we're going to show just a very simple how to install Falco using Docker and run it. We'll look really quickly at the rules file, and then we'll kind of just show some of the things that Falco can detect. We'll talk about somebody trying to write files below /bin. We'll show what happens if somebody tries to run bash inside a container. In this case, we'll be doing it via a node.js application with a very poorly designed REST API. And then we'll talk about something that was related to a blog post we did a couple weeks ago. So talking about this idea of these downloadable install scripts that you kind of run as root, and talking about how they can be hijacked to trick you into installing malicious software, and then how Sysdig Falco can detect that. And then we also have, like I said, we have a blog post. Here's the link to the blog post in case you want to read up more about it. Okay, so now let's go into the demo. Let's see here. A second. Okay. So here's the big old Docker run. So I think the font size is okay. Everybody should be able to read it. Okay. So here's the big old Docker run command. So we'll just fire it up. It downloads it from Docker Hub. It actually builds a kernel module on the fly that matches your running kernel version. This is just like Sysdig, so this part's the same. Okay, so now it's running. In this case, it's running in the foreground. You can see the output that it's all ready to go. So the first thing we'll do is let's try writing something to below bin directory. So in this case, we'll just try to touch a file bin hacker. Maybe a real hacker wouldn't use such an obvious name, but you know. I'm not that smart. Okay, so we do that, and you can see in the Falco output, it noticed that activity and sent an alert based on it. So it said, here's the message. It said, a file below a known binary directory was opened for writing. And then we have information on who it was, what the command was, and what the file they were trying to write. So that's pretty good. You know, we're already detecting bad activity. Let's actually, just to see what the rules file looks a little bit more. So here's the actual Falco rules file. So we already looked at one rule in the slide deck, but you know, here's the actual set of rules that are in the product right now. So here's the rule that was just triggered. So it's write binary dir. We have a description. Here's the condition that says what activity it was looking for, and the output. And so the way it plugged in that stuff about root and the command was based on these fields right here. So looking at the username, the command line. So the output field is kind of nice. It's, you know, it's a nice mix of a good description, and then you can pull out the interesting information out of the event and put that together. Okay, So let's stop that one and let's move on to this idea of running a shell inside a container. So let me just set it up a little bit and kind of give you a description of what's going on. Okay, so this is a really simple Node.js application using Express. And the idea is here is, okay, let's say somebody designed a, they set up a server with a REST API, but they designed a really bad API. And so if you're not familiar with Express, I'll just describe it. It says, okay, I'm going to set up my web application under the endpoint /API. And below that, I'm going to say, oh, well, maybe I want people to run, I want a really flexible way for people to run commands, and I don't want to deal with super complicated things. So I'll have something called exec. And if it's API exec something, that's CMD, I'm just going to go run that and send the output to it. So I'm sure if I tried to write software based on this, I'd get fired, but maybe somebody else ended up doing it anyway. Okay, so the idea is that we're going to show what the weakness of this is and also show how Falco can detect it. And if you want to look at these examples, we actually have them on GitHub, and they're all runnable via Docker Compose, so it's pretty easy to work with. So we'll just fire up everything. So it's in this case, we're starting two things. The first thing that we're starting is the Sysdig Falco. It's still run in the container exactly as we ran it before. And we've got this Express server, which is the JavaScript thing I was just showing, the Node.js thing I was just showing you. So Falco's all set up and running. So now what we're going to do is we're going to kind of show what these URLs can do. Okay, great. So if you connect to localhost API exec ls, it runs ls, sends the output to you, and you can see what's going on. So that's great for innocuous command. Well, I'm not, maybe you should never do this, but you can do things like pwd. But let's say you wanted to, you're a hacker and you figured this out, and like, oh, well, I'd just like to get a shell on the remote machine. So how do I do that? So let's just change the argument of exec to be bash. So you do that, and Falco actually detects the activity. So it says, okay, somebody tried to spawn a shell in a container, and it wasn't kind of at the entry point. Kind of when you start up containers, you might expect shells to occur, but certainly not once containers are already running. So we have a Falco rule based on that. It detected the bad activity and filled it in with details on what happened. So we can say it was root. Here's the container name. So this is, giving you an example of all the great stuff that Sysdig can give you with respect to container visibility. And here's the details on what they were trying to run. They're trying to run bash. All right. Okay, let's stop everything, and we'll kind of move on to the next example. This one's a little more fun, but a little more complicated, so we have to. Okay. Okay, so this final example that we're going to show is kind of talking about these downloadable installation scripts and how they might be hijacked to install rogue malicious software. And then also we'll talk about how Falco can detect it. So here's kind of like the setup for the hypothetical scenario that we're talking about. So in the upper right, we have some components set up by the software vendor. So let's say they've got install software.sh sitting on some file system somewhere. They've got some web servers like Apache, what they're using to serve the software and these installation scripts. But in front of it, let's say they have something like Nginx acting as a reverse proxy. So this is really common. People use Nginx for things like SSL termination. They use it for load balancing, maybe caching of static content like images. So it's really common to see, web servers with reverse proxies in front of them. So in this hypothetical example, there's also an attacker out there. So they're running an evil Apache, like their version of Apache, where they've got some malicious software set up to send to people. And let's say they're running a botnet, so they've got like a command and control machine as well that's sitting there trying to find new clients to add to its botnet. So in this case, let's say the attacker got into that Nginx box, so that's why I colored it orange. So if they get into this Nginx machine, they have the ability to kind of change the contents of this installation script on the fly as it's being downloaded to the client. Oh yeah, so the client's the box on the left, so it's running curl, install software, pipe to bash. You know, it's probably running it as root because that's how you install your software, but that's incredibly attractive to the attacker because they can basically install and run arbitrary software on the client as root. So that's a horrible, horrible situation to be in. And then on the client, we'll also have Falco running, so we can use it to detect this activity. So if the attacker can get into the Nginx machine, they can change this script on the fly as it's being downloaded to the client. And that's especially tricky to detect because there's no like copy of the software, there's no copy of the installation script that you can look at to see that it's been modified. It's only being modified in flight between the software, the server and the client. So it's especially tricky. So you might be wondering, how do you actually write Nginx to do that? So let me show you. So here's how you do it. You may or may not be familiar with Nginx configuration, but this line here with the subfilter is the important piece. So it's saying, I'm going to take the piece of the script that has this install deb line, and I'm going to replace it with more stuff. I'm going to say, also download this script called botnetclient.py from, in this case, it's localhost, but this is the evil Apache server, and I'm going to run it. This is running as root now because you ran the installation script as root. So now the attacker has basically got a Python script running on your machine as root. So goodness knows what they can do at that point. Okay, so now that we've set it up, let's kind of, oh, actually, let's keep this. Let's kind of go through the steps of watching what happens. Like I said, this is also available on our GitHub. It's all available, all runnable via Docker Compose if you want to run it as well. So it's just starting up everything. Like before, Falco's building the kernel module and linking it to the kernel, the version of the kernel. So if we look at Docker PS to see what's actually running, we've got the Apache instance, which is the one run by the software vendor. We've got the Nginx instance owned by the software vendor, but compromised by the attacker. We've got the evil Apache, that's going to be the one serving the Python script. And we've got this botnet master, which is probing into the client machine, trying to get in. In the output up here, we've got in this attacker botnet master line, this is basically that software trying to get in. Okay, so now let's try to install this software and see what happens when we do that. Okay, so a few things happened. In the bottom, the installation script was downloaded and run totally fine. Don't worry about the root thing, that's not important. But you know, as far as you know, the script worked just fine. But a few things changed in the top screen. So let me just take we'll look at this. So if you look at the Apache instance, it served out the legitimate copy of the installation script. So did Nginx, but it was modified on the fly due to those rewrite rules that I showed you. Also, the evil Apache instance, it served out a copy of the botnet client script. So that's evidence that this is running on the client. And then also in this, the botnet master output, it changed. So it actually can reach the client machine now, and it's sending it, you know, fake commands. In this case, we're saying, go DDoS some IP address and do bad things. And let's look to see what's running on the client machine. Hey, there's this botnet client Python script. Where did that come from? I've never heard of that, but it's running now just as a side effect of running this installation script. And if I tell that to localhost, hey, the Python script, it's running a little network server, and hey, it's waiting for command and control commands. So this is pretty horrible, right? You thought you were installing some piece of software, and now you've got this rogue Python script running on your machine with a network server waiting for connections from someone. So that's a pretty horrible place to be in. Okay, so let's kind of talk a little bit about how Falco would detect this activity. Let me just get everything started from scratch. Okay, so yeah, I don't need to show the script. The basic idea that we have in Falco is we're going to use this idea of process sessions, which is basically a way to group processes together. And what we're going to say is, if we can find a way to isolate all of the programs that are running as a part of this installation session, then we can that as a kind of like a policy scope to a scope upon which we can apply rules. We can say, during an installation session, only certain activities are allowed. And we have rules in the Falco Rules file that do exactly that. So let me just show a couple examples of them. Okay, so here's one of the rules that we use. So what this says is this proc.sname, this is the important thing. We're going to basically run everything under a different installation program called fbash, which is basically Falco Safe Bash. And the thing that that program does is it creates a new session group that basically takes all of the things that are running as a part of this installation process and groups them all together. And what the Falco rule does with that is says, okay, if you're in one of these sessions related to fbash, you can't start a network server because that's not something you would reasonably expect to see as a part of installing software. And here's the rule for that. Another thing you might see happening is, so you see malware often connecting to things like IRC servers and so forth and connecting on crazy ports. So another thing you can do is you can say, if you're in one of these fbash sessions, there really shouldn't be anything making outgoing connections on ports other than HTTP. You know, you would expect the download to happen for downloading RPMs or something, but you shouldn't expect to see somebody connecting over IRC ports or crazy ports or anything like that. So we have a rule for that in the Falco Rules file as well that says if you're in one of these fbash sessions and you make an outbound network connection and it's not one of the ports you expect to see, then that's suspicious activity that you should send an alert for. Okay, so now let's, did I have everything? No, yeah. Let's start up everything again. And we'll kind of go through the same steps, but instead of running it through bash, we're going to run it through fbash. And we'll see how that allows Falco to detect the suspicious activity and send alerts based on it. Get in the right directory. Okay, so we've got everything started again. We've got the good web server, the evil web server, and everything. So the difference here is that we're going to run things through fbash instead of bash. And we'll see what the different behavior is now. Okay, so in the bottom, everything was the same. So you ran the installation script. The botnet client is still running as a result of doing the installation script, and the kind of the attacker can get through. But there's some other things that happened. If we look at the Falco output, it sent a bunch of new alerts. It said, okay, I saw an outgoing connection on a non-HTTP port. Because remember we said that, well, in this case, it was downloading it from the evil web server, which is running on a non-standard port. But so that one's interesting. But the one that's really interesting is this one about the listen call. So it said, hey, I noticed that that Python script started up a network server, and we don't reasonably expect things in an installation session to start up network servers. So Falco detected that activity and sent an alert based on it. So, you know, getting back to that home security analogy, this didn't prevent the intrusion, but it absolutely detected it. So it gives you kind of a safer way to detect that an intrusion occurred. It gives you kind of a safer way to do these kind of all-in-one downloadable installation scripts, even in a case where somebody was able to change the contents on the fly. Okay, so that's kind of our demo. So I just have a couple more slides and then we'll wrap up. Okay, so if I haven't convinced you yet that you should be excited about Falco, I don't know what else I can do, but there's lots of ways that you can come hear more about it. So we've got a website where you can hear more about it. We've got a Google group where you can join for support or ask questions or ask for features and stuff. We have public Slack, just like we have for Sysdig. There's a Falco channel. Here's the link for it if you access it via the web. And we've got a blog with all of our blog posts. If you're interested in that man in the middle thing, we've got a really long write-up about kind of going through all the steps that I went through. If you're more interested in the software itself, it's all available on GitHub, you know, open source. Everybody can access it. Pull requests are obviously welcome. If you have your awesome ideas for new rules or features you want to add, please let us know. You can file issues and then we'll try to write it for you. We've got a wiki under GitHub that kind of describes like how to use it, how to download it, how to build it from source and so forth, all like the nitty-gritty of you know, how to use it on a day-to-day basis. And everything's also available on Docker Hub, so if you just want to run our builds via Docker, that's the way to go for that. And that's it. So that's kind of everything that we had to talk about Sysdig Falco. So at this point, I'll kind of open things up for questions. Anybody have anything they want to talk about? Knox wants to.
So we got a first question came in. It said, could it be possible to use Sysdig Falco to set up a high interaction honeypot?
High interaction honeypot. I think, yeah, well, I'm not sure what high interaction means, but you could definitely set up Falco to basically set up a, you know, like I guess with a honeypot, you'd have some machine that's got a bunch of vulnerabilities on it, and you kind of let people get in and see what kind of bad things they do. I think Falco would be great for that. So I think if that's kind of what you're talking about, like use Falco as the way to monitor the behavior of intruders and use it to define new rules. That is definitely something you could do. Anyway, let's see. Oh, here we go, chat. Let's see. Okay, so there's another one. What package managers does Falco recognize as authorized to modify bin? Here, let me just show you in the config file what we use. So, can I? Oh, here, let me. Oh, yeah, I'm still sharing. How do I hide this thing? Okay. So here's the macro that actually defines that. So here are the programs that are allowed to modify things below bin. We actually have other sets of programs as well. So package management and other pieces of software can modify these contents. So this seems to work fairly well for dpackage and yum. You know, we definitely can iterate on this if you find other pieces of package management software that you want to add. So. Is that all the questions in here? I think I lost my chat window.
How would you go about executing commands upon alerts?
Oh, yeah, so I think that would probably be, something that we would add kind of outside of Falco. So we definitely want to be in the game of sending alerts, acting on alerts. I think there's already lots of great software out there, and you know, I think it would be easy to hook up maybe something that looks at syslog to act on things. Maybe if we add Slack integration in the future, you know, that's almost becoming a universal messaging mechanism. And we actually just had a blog post this week talking about how we can route how we can route Slack messages directly into our own Sysdig cloud platform as events. So it would be fairly straightforward. I think there's a lot of techniques to do that. And I think we would probably rely on those things to make that kind of stuff happen.
Another question came in. What's the difference between Falco and OSEC?
I think they're pretty similar. I mean, I think the strength of our stuff is it's really got this rule system behind it, and it uses Sysdig's filtering expression. So I think they're similar. I think, you know, we're just coming from building on the strengths that Sysdig has. So. Oh yeah, and Knox included the link to Phishing for Hackers. That's like a good example of. And then there was another one about, or was that the one that talked about the guy who got in and kind of watching the behavior? Yeah, so that's a great blog post related to it. So. All right, any other questions? Otherwise, we'll kind of wrap it up. Oh, looks like there might be another one coming in.
Does Falco send out email alerts?
Not directly. We kind of the other question about what actions do you take based on an alert. I think that's best handled by acting on syslog. So there's great ways to hook up with syslog and emails. You know, that's pretty straightforward. So it doesn't directly send the emails right now, but I think we can definitely add a good set of alert mechanisms to make sure other people can send emails. Just thinking a little bit about how Falco works with our main commercial product, Sysdig Cloud. We're definitely planning on adding support for it, and we want to make it a big important feature of the Sysdig Cloud product. So I think coming soon, you would definitely expect to see the great features in Sysdig Falco put into the cloud product. So in addition to monitoring performance and activity, you can also have the security component as well. All right, anything else? Otherwise, thanks everybody for hanging out with us and taking a look, and go download it and play with it, and get excited, and hopefully you can use it as in all the great ways that we're already using it here. All right, thanks. See you later.